Welcome, class, to Chapter 6, Network Security Devices, Design and Technology. So today's objectives are to list the different type of network security devices and how they can be used, describe network architectures, and explain how network technologies can enhance security. So security can be achieved through using security features found on standard networking devices. And the beginning of this slide deck is probably going to be reviewing some basic networking terminology that you guys should be familiar with due to having a pre-advisory course of networking before coming into CISS 310. If you guys did not have the pre-advisory networking course, I think most of this class is a little more on the difficult side if you don't have any networking experience. Highly recommend, even if you're going through this course, to go back and pick up on some networking courses just so you can piece everything together. So standard networking devices, as you know, they work at the OSI layers, and each layer is codependent on the next. Some devices include bridges, switches, routers, load balancers, and proxies. Bridges are just hardware device or software that is used to join two separate computer networks to enable communication, so you can connect two LANs together. Operate at the data link layer at level 2. Most operating systems allow for software bridges to connect to two networking system segments. Probably, if you're not really working in the professional environment yet, specifically in networking, you probably see the term bridge used more in when you want to create virtual machines. You can choose a bridge network or a LAN network, but creating a software bridge could eventually create a security vulnerability. And if you open up your network connections, you can actually turn on bridging. Switches is pretty self-explanatory. If you've taken a networking course, you should know this. Device that connects network hosts intelligently. It works on the layer 2 layer, the data link layer. It examines the MAC address of frames that it receives and associates its ports with MAC address of the device connected to that port. It forwards frames intended for a specific device unicast instead of sending it out of all ports broadcast. So pretty much, if a computer needs to talk to another computer and it has its MAC address, which are on the same LAN, the host or computer A will send out a packet. The switch will then that's a bad word to use might get confusing, but it will pretty much redirect that traffic out the port which the computer B is connected to, because it knows its MAC address based on a MAC table within the switch. And it's important to have proper configuration otherwise within the switch. Otherwise, security vulnerabilities can show up. You can create loops, or you can flood the network. And you can compromise a MAC table. If your MAC table is compromised, you could be sending specific data to a spoofed host. So that could be so it's important to have correct security controls around the switches. So flood guard, essentially, flooding means that the switch sends the incoming frame to all occupied and active ports, except for the one that the packet was received on. And in essence, flooding is when the switch pretends it's a hub and just sends a packet out on all ports, active ports on that switch. And there are essentially two ways that the flooding happens. It's when a switch receives a broadcast and it has broadcast packet and has no choice to send it, but to send it out to all active ports, or when the switch receives a frame dedicated for a particular destination, but it does not have its MAC address. So what the switch has to do is send it out off of all ports to find that MAC address, to map it, and then send the packet to that specific host. And essentially, to prevent flooding, what specifically for Cisco switches, what they do is they have port security, which port security is essentially, it provides the ability to limit what addresses will be allowed to send traffic on individual switch ports within the switched network. This is actually a very important concept in if you decide to take your CCNA, your Cisco Certified Network Associate certification. Switch port security just limits the number of valid MAC addresses allowed on a port. And if the maximum number of secure MAC addresses has been reached, a security violation occurs when devices with a different MAC address tries to attach to that port, and it sends off a trigger. So routers works at the layer 3. They have access control lists. It can be set to filter out specific types of network traffic with ACLs, access control list. A lot of home routers act as also a firewall. And essentially it routes your traffic based on IP addresses and forwards your packets to different networks. A load balancer, it's pretty much what it sounds like. It balances your load. So not only does it provide fault tolerance, but it helps evenly distribute work across the network. So not one resource will be too stressed. Instead of one device working at 90% capacity, you have two devices working at 45% capacity, and if one goes down, you have the other just in case. Advantages of load balancing: reduces probability of overloading a single server and optimizes bandwidth of the network computer. So essentially, things go faster. Load balancing is achieved through software or hardware devices. F5 networks, that's a very popular load balancer that I've used before. Load balancers are grouped into two categories essentially: layer 4, which works on the network and transport layers, and layer 7, which works on the application layer. And different scheduling protocols are used in load balancing: round robin, affinity, and then some other types. Round robin is, they take turns. And then affinity is essentially the load balancer will always use the same server for a particular user or an instance, specifically a session, which usually is at the to a specific application server. Now, proxies. There are several different types of proxies within a network. There's a forward proxy, which is a computer and application program that intercepts user requests from an internal network and processes that request on behalf of the user. So whenever a computer is trying to talk out to a different server or a host, there's a server that sits in front of it, and that server communicates on behalf of the user. Application multipurpose proxy, a special proxy server that knows the application protocols that it supports. Reverse proxy routes requests from an external network to the correct internal server. So while a forward proxy is a proxy for like workstations and computers, a reverse proxy, you can kind of think of it as a proxy for a server. So if one of your servers needs to talk out to a external network, which is one of your internal servers needs to talk out to an external resource outside of your network, you put something in front of it, so it's server to server rather than computer to. Rather forward proxy is kind of like a computer to server application. A transparent proxy, essentially, you can't tell that does not require any configuration, and it's transparent to the user. You don't see, or the user's not affected. As it says, does not require any configuration on the user's computer. So, as you can see here, as I mentioned, a forward proxy, right? It sits in between the computer and the server, and then a reverse proxy sits between the server, server and an external resource out here. So always think forward proxies for computers, reverse proxies for servers. That's kind of how I think of it in very, very layman's terms. Advantages of proxy servers: increased speeds, reduced costs, improved management, stronger security, because you're actually not advertising your IP address. So specifically designed security hardware devices provide greater protection than standard networking devices. So what this is saying is, if you have a dedicated firewall or dedicated router that does routing, those are a little more stronger than those everything built into one home routers that also act as a firewall, if you know what I mean. So firewalls can be software based or hardware based. Both types inspect packets and accept or deny entry. Hardware firewalls tend to be more expensive and more difficult to manage and configure. Software firewalls running on your device only protects you from your device. The hardware stuff you can put it outside at the perimeter of your network and can protect things coming into your network, but the software is only on the host. I recommend having on the perimeter the different types of firewalls on your host. It's if you ever have gone to Microsoft, if you open up your control panel on your Windows 10 machine or Windows 7 machine, whatever it is, you guys should upgrade to Windows 10 if you guys have Windows 7 still. You can go to Windows firewalls and you can play around with some of those ports or some of those lists to just play around with it, see how. I think there's a lab here that also shows you access control lists. You guys will go through it. Software firewalls. All modern operating systems include a software firewall, usually called a host-based firewall. Yeah, and for Windows, it's called Windows Firewall, if I'm not mistaken. And it's like red and green dots to determine if it's closed or open. So enterprise firewalls. By the way, firewalls and routers are really heavy if you've ever tried to lift one up. So That's just something fun to say. So Windows firewalls, if you go to your firewalls page, it should look like something like this. And then if you actually click here, it will open up different things you can block and open. So here, so a network firewall, in this example, you actually have the firewall right after your router. So your switches connect, so your switches inside your network will be behind your firewall, and then your router will be outside of your firewall, connected to the internet. So methods of firewall packet filtering. So there's essentially two types, stateless and stateful. Stateless essentially just inspects incoming packets and allows or denies based on condition. Stateful actually looks inside the packet. It looks inside the payload, and keeps to make decisions, and also it records the state of connection. So if it's already allowed the specific user to come in, then it'll allow it to come in back again. Firewall actions, you can either allow, drop, or reject. Allow, let the packets go through. Drop, prevent the packet from passing into the network and send no response to the sender. Reject, prevent the packet from passing into the network but send a message back to the sender. It did not get in. So rule-based firewalls use a set of individual instructions to control actions. Each rule is separate instruction process in a sequence telling the firewall what action to take. Usually it goes by what's it called? Not sequential order. It goes by sequential order. So if you have like 10 rules within a firewall in an access control list, you put your rules in the access control list, and if you have 10 rules in there, it will always go from rule 1. It'll go in sequential order. So it'll check rule 1. If it matches a condition, it'll let it through. If it doesn't, it'll go to the next rule, rule 2. If it matches the condition of rule 2, it'll either allow, deny, or reject, or if it doesn't meet any of those conditions, then it'll drop down to rule 3 and check against those conditions. So it'll go down the order of rules until it matches a condition. Usually, the very last condition you want to put in an ACL is a deny by default or deny all, just because you don't want everything to you don't want anything to just randomly come in. But I mean, there's always specific exceptions. Rules are stored together in one or more text files that are read when the firewall starts. Rule-based systems are static in nature, cannot do anything other than what they've been configured to do. So the deny by default, what I'm talking about is mostly on routers, by the way, not on firewalls. You could do it on firewalls, but I'm mostly talking about routing, allowing people into your network. So application-aware firewalls operate at a higher level at the layer 7. Usually we call these WAFs, or web application firewalls. They operate at a higher level by identifying applications that send packets through the firewall and make decisions about actions to take. Applications can be identified by application-based firewalls through predefined application signatures, header inspection, and payload analysis. Web application firewalls are special types of application-aware firewalls that looks deeply into packets that carry HTTP traffic, or port 80, and can block specific sites or specific types of HTTP traffic. Now, virtual private networks, VPNs, you may have heard this term multiple times. I think it's really important that everyone actually understands what a VPN actually is. VPN is not an internet connection, it's a secure way to access the internet. Normally when you want to access the internet, you use your computer and you directly go to a website or some internet site, internet resource, and you directly connect to it. Now, what a VPN does is essentially let me back up. So when you go from your computer to an internet or external resource, it's fast, but it's rarely secure, and that traffic, it's going through your ISP or internet service provider, and it can be easily traced back to you. Additionally, something that's bad or a downside of not using a VPN just straight off the bat is that ISPs tend to take your information and sell it to people. So but something that a lot of people worry about is the security, and you can be tracked. So now a VPN, what essentially it does is, let me see if there's a picture. Don't remember if there's a picture. Okay. So essentially what a VPN does is that it encrypts your traffic. And additionally, it encrypts your traffic and encapsulates it, and it sends it to a different server in a different location. It can sometimes be in a different city, different country, but at that point, when you're trying to reach out to the internet, you essentially route the traffic to that specific server, securely encrypted, right? And then that server on your behalf will talk to the internet or talk to the external internet resource that you're trying to access. And not only are you keeping your data safe, it allows you to mask your location by making the internet think you are located wherever that server is, not where your house or your office is. It can spoof the internet in thinking you're at a different location. So if, for example, this is helpful for people that are on the road or you're trying to access some media content or resource that's blocked in a specific geolocation. So, for example, I don't know if you've ever been on YouTube, you try to access a video and it's like, oh, you can't access it because you have to be in the UK or you have to be, in China, right? When you have a VPN, it allows you to pretend you're at a different location to access other things. And so, this encapsulation of your data, it's essentially called a VPN tunnel. A VPN tunnel essentially works by encapsulating data in an encrypted data packet. And an analogy you can think of, it's like the act of putting the postcard into an envelope, right? The envelope is, you're encapsulating it. And that's kind of what you're doing. So the postcard that you have, pretend that's like the data, and then if you put it in an envelope, you're essentially encapsulating it and creating that VPN tunnel, sending it to the server, which speaks on your behalf. And that's what we usually call VPN tunneling. Now, the only problem with VPN is that it's it's kind of slow, increases overhead because with all that encryption and rerouting traffic, it's obviously going to deprecate your speed, and it's going to be some overhead. But essentially, if you really don't use VPN, it's really easy to snoop on your traffic, specifically if you're on public Wi-Fi. And another downside of, I mean, I highly recommend people use VPN, but it doesn't cost that much to get your own personal VPN. I mean, yeah, there are free VPNs out there, but nothing. There is no free lunch, right? There are always known vulnerabilities with open source VPNs, or they can be selling your information or display a lot of ads. Long story short, VPNs are something that you guys should really start thinking about using during your personal in your personal life. Just because you get to mask your location and you're securing your data while you're talking to the internet or going on the internet. Types of VPNs: there's remote access VPNs, so the user to a LAN connection, site to site. Multiple sites can connect to other sites over the internet. And then always on VPN, allow the user always stay connected. Let me see. So a remote access VPN is essentially you're a user. You bring your laptop home from work and you connect to your internal network at your work. So that's kind of like a remote access VPN. Site to site, it's pretty much if one of your networks needs to talk to another network. It can be either you have two different networks, or you have a partner company. You need your sites to be connected, right? And then always VPN, always on VPN, allow the user to always stay connected. Endpoints, the end of the tunnel between VPN devices, maybe software on local computer or VPN concentrator. So VPNs, it can either be local computer or on VPN concentrator. Yeah. So a VPN concentrator is a dedicated hardware device that aggregates hundreds of thousands of VPN connections. When using a VPN, there are two options. All traffic is sent to a VPN concentrator and protected, called a full tunnel. Only some traffic is routed over the secure VPN, while other traffic directly accesses the internet, called split tunneling. So I also wanted to mention that, or to go over again, that a hardware VPN is a hardware VPN that runs your network through a dedicated piece of equipment which has its own processor and firewall. This type of VPN, is better for, it's more expensive, but it has increased security and speed. And then a software VPN, it's essentially you have a server, you put that VPN software on that server specifically, and the best advantage of software VPNs are it's affordable and scalable. So hardware VPN, it's a dedicated server you buy just for VPN. Software server VPN is, you have a server and you put a VPN software on it. And now, technically either one can be a VPN concentrator. As we discussed here, it aggregates all the VPN connections. And something that I wanted to also mention is that these slides don't talk about is that so usually regardless, you have on the client side, right, you have a software that you specifically as the user use as a VPN service, and that's called the VPN client, right? That software software is on your computer, right? And when you want to connect to your VPN concentrator, right, that's called the VPN server, to say. And essentially the encrypted connection always start with the VPN client making a request to the VPN server. And there are different types of VPN connections or encryptions that happen. The most popular are L2TP, IPsec, OpenVPN, PPTP, and these are some of the protocols that you'll go over in your book. Um, but I wanted to go over some of these because some of these topics real quick, just because they didn't go over them in the slide. Um, okay, and there are now VPN clients where it's actually all web based. So those are pretty cool. So now Mail Gateway, essentially there are two different types of email systems in use. So Mail Gateway, we're talking about sending back and forth email. So when we want to send email, we use SMTP, which is port 25. And that's when we want to actually send email. However, if we want to receive email, we will use either IMAP, which is port 143, or POP, which is port 110. And essentially, the difference between POP and IMAP is that IMAP retains that email on a server and it can be synced with all your different devices at once. And then POP or POP3, essentially you download that email and then you can use it offline and it gets deleted from the email server. So a mail gateway essentially monitors emails for unwanted content, prevents these messages from being delivered. For inbound emails, a mail gateway can search for various types of malware, spam, phishing attacks. For outbound email, a mail gateway can detect and block the transmission of sensitive data. Nowadays, there's a lot of cloud access brokers which inspect the type of data that's being sent and can either block or active or send alerts of when specific data is being sent out to prevent data exfiltration. So, network intrusion detection and prevention systems. So, intrusion detection system, what is it? An IDS, essentially, an IDS is a device which looks at network traffic and determines if it's suspicious activity or not, and then it alerts you. It doesn't do anything active or prevent it. It just monitors your traffic. There's two types of IDSs, inline and passive. And inline directly sits in front of your network, in front of your firewall, and in front of your firewall, and just watches the traffic coming in, right? And then it will, send off a trigger if it finds something. Now a passive IDS, it's connected to a port on a switch and receives a copy of network traffic that's coming in. And that's kind of like port mirroring. If you've ever, played around with Cisco switches before. And IDS systems can be managed either inbound or outbound through the network itself by using network protocols or using an independent dedicated channel to reach the device. And as we mentioned, inline and passive. Inline, the connection is directly to the network, and the traffic flow is routed through the device, while passive is connected to a switch port and receives a copy of the traffic. So, monitoring methodologies. So what are the different ways of the IDS being able to detect suspicious activity? Right? So there are essentially four types: anomaly, signature, behavior, and heuristics. Anomaly, essentially you have a baseline and it compares your baseline. It develops a baseline over time. It compares it whenever something happens. If it's not part of your baseline, it'll detect it as suspicious and send out a trigger for you. Signature, it just looks for well-known signatures or patterns based on an external database, either you're keeping or a vendor's keeping. Behavior based, detects abnormal actions by processor programs. You can kind of think of it as like a police officer looking for odd behavior in a suspect. And it alerts users who decide whether to allow or block traffic. Now, heuristics monitoring uses experience-based techniques, kind of similar to signature-based, but they seek to identify and look and actually look inside, looking for what's the best way to put this? It looks, I don't know if looking inside is the best term for it, but based on, it's kind of like signature based, but it uses experience based techniques, meaning it looks for suspicious activity within the traffic. So there are two different types of IDSs. One is host intrusion detection system, which is a software-based application that can detect an attack as it occurs, installed on each system needing protection. It monitors, it essentially monitors system calls and file system access, can recognize unauthorized registry modification, host input and output communication, detects anomalous behaviors. Now, the disadvantage of host intrusion detection systems, it cannot monitor network traffic, which I was, talking about earlier when I was saying, you put outside of your firewall. All the log data is stored locally. Technically, if something gets in, it can get wiped, and resource intensive and can slow down your system. Now, a NIDS, network intrusion detection system, that's when I was talking about outside of you usually want to put your IDS outside of your firewall. Watches for attacks on the network. NIDS sensors installed on firewalls and routers, and gather information and report back to a central device. And they're application aware. A specialized IDS uses contextual knowledge in real time. It can know the version of the operating system of which application is running, and it can fingerprint it, as well as what vulnerabilities are present in the system being protected. So now IPS, right? So we talked about IDS. Now the main difference is IDS is it just looks at the traffic. It does not actually prevent it. An IPS, intrusion prevention system, prevention P, right? It monitors the network traffic, immediately blocks a malicious attack. So it's more active. It's not passive and sitting back. It's similar to NIDS, NIPS, network intrusion prevention system, located inline on the firewall. When they say on the firewall, they're usually referring to behind, either within the firewall or behind the firewall if you have it separate. Allows the NIPS to more quickly take action and block an attack. Application aware IPS knows which applications are running as well as the underlying operating system. So a SIM, a security and information management system, right? Essentially, it's a product which that aggregates all your logs for every system you have. And when you aggregate you point all your logs to a SIM, and it allows you to do incident response or monitor, troubleshoot network, or look at suspicious activities. Some common SIMs are Splunk, if you've ever heard of that. Microsoft's Sentinel-1, Exabeam. But essentially, it's a separate. McAfee has its own SIM as well. Essentially, a SIM is a separate device, software that's run on a computer, and a service that's provided by a third party. Right, it's a product. This one specifically, I don't know what SIM this is. Alien Vault. But essentially it just aggregates all your logs together in one central single pane of glass to be able to troubleshoot or do incident response. And then you can correlate different data together because you have all your logs coming into one. And you can set automated alerting and triggers. And it's pretty much, if you're in the public sector, you will, right now it's not required to have a SIM, but down the line, I think in a year or two, it's going to be mandated that all state departments have to have a SIM in place. Usually private sectors, they already have one if they have a security team. So other network security hardware devices, we have a hardware security module, which is a detailed cryptographic processor that provides protection for cryptographic keys, an SSL decryptor, a separate device that decrypts SSL traffic. Usually nowadays they're on the firewall itself. An SSL TLS accelerator, a separate hardware card that inserts into a web server that contains one or more coprocessors to handle SSL TLS traffic. Processing, media gateway, a device that converts media data from one format to another. UTM, unified threat management, integrated device that combines several security functions. Internet content filter, monitors internet traffic and blocks access to pre-selected websites and filters. Files, usually web security gateway, blocks malicious content in real time as it appears without first knowing the URL of a dangerous site. Essentially, all this stuff, most of this stuff is integrated into, single products now, like firewalls. I mean, I can tell you right now that firewalls, they are out there that also do internet content filter and web security gateway at the same time. So security through network architecture. Now that we've talked about all that, those devices, now let's talk about the design. So the design of a network can provide a secure foundation of resisting attackers. Elements of secure network design is creating security zones, and those security zones will have different levels of permissions and access, and using network segregation. Not having a flat network. Network segregation, we're trying to prevent east-west traffic. One server talking to like your development server talking all the way to your production level server that has credit card information. You have to have some not separate, wrong term for separation between them. So DMZ is a separate network located outside secure network your perimeter. Essentially, it acts as an environment where untrusted resources can connect in. So untrusted outside users can access the DMZ, but not your internal secure network. So if you need something to be accessed by external people, you usually put it in your DMZ because you don't want direct access from external people into your network, right? So you put it in a DMZ. The DMZ is actually, you can kind of think of it as like a middleman. So external resources can access your DMZ but can't access your internal. And so, for example, right here, it'll, if someone wants to talk to you internally, it will actually go to your DMZ. First, it'll route the firewall here will route it to the DMZ. So network address translation, NAT. So as I said, if you've taken networking, you should have taken networking. Otherwise, this is a lot of information to digest. Allows private IP addresses to be used on the public internet. Replaces private IP address with a public IP address. So those reserved private IP addresses. So essentially, you have one. You can use a public IP address, which will be the address that it looks like you're talking from, and everyone will have in your network will have a private IP address, but you can't use that private. No one can actually from the outside communicate to you based on your private IP address. And advantages of NAT is it masks your IP address of internal devices. An attacker who captures a packet on the internet cannot determine the actual IP address of the sender. So essentially, the 192.168/16 IP range, that's one of the ranges for a private IP address. When you have that specific range, so if your company's IP or firewall's IP address, whatever your public IP address is, 192.146.118.20, essentially all your devices within that network will use that one IP address and talk to external resources. And everyone inside of your network will use an IP address within the 192.168.0.0 range, or 10.0.0.0 range, or 172.16, right? So intranet, a private network that belongs to an organization that can only be accessed by approved internal users. Extranet, a private network that can be accessed by authorized external customers, vendors, and partners. Guest network, a separate open network that anyone can access without prior authorization. So essentially, the recommendation is don't have a public Wi-Fi. I mean, if you have a Wi-Fi, if users need to access Wi-Fi, create a guest network for them. That's completely off your network from your internal Wi-Fi and environment. Create a guest network. They can do whatever they want on that. So physical network segregation, isolate the network so that is not accessible to outsiders. If you have everything in a data center, lock it up. Only users who need to access that data center to be able to get in there. Make sure you have logs of who comes in and out. Air gap, the absence of any type of connection between devices. In this case, the secure network and another network. So if something does not need to talk to something else, don't connect them. Networks can be segmented using switches to divide the network into a hierarchy. So core switches reside at the top of the hierarchy and can carry traffic between switches. Workgroup switches are connected directly to the devices on the network. So this is all network segregation, right? Virtual LAN. So you put everything in different VLANs, allow scattered users to be logically grouped together, even if attached to different switches. Usually when we're talking about network segregation, a lot of people in the industry usually refer back to putting people in different VLANs, right? And having them providing them different security restrictions. And it can isolate sensitive data to VLAN members. So for example, when you create a VLAN, you definitely want to put all your legal team in that VLAN network, because there may be some specific sensitive data that they should only be accessing to and others should not. Your accounting should be separated, your IT, right? Communication on VLAN, if connected to the same switch handles packet transfers. A special tagging protocol is used for communication between switches. So essentially, if one person needs to connect to another, you get tagged. It's a tagging protocol. We won't go into detail because this is not a networking course, but so networks. Did I go through this? Yeah. Security through network technologies. Two technologies that can help secure a network: network access control, a NAC, or data loss prevention. So a NAC examines the current state of a system or network device before it can connect to the network. Any device that does not meet specified set of criteria and connect only to a quarantine network where the security deficiencies are corrected. And then the goal of a NAC is to prevent computers with suboptimal security from potentially infecting other computers through the network. A NAC uses software agents to gather information and report back to host. An agent may be a permanent NAC agent or a dissolvable NAC agent, which disappears after reporting information to the NAC. A NAC technology can be embedded within Microsoft Windows Active Directory domain controller. A NAC uses AD to scan the device, called agentless NAC. So essentially, if a computer is not up to speed with its security, controls, patches, something like that, the NAC can prevent it from getting into, being able to talk to everything else. Also, you can prevent devices from connecting into your network with a NAC. So additionally, I want to mention that a NAC, it does, as I mentioned, it looks based off specific conditions of, a device. In practicality use, I've seen it used for, hey, if this device does not have a certificate and is not part of our IP address, then we won't allow it on our network, right? Or if this certificate is expired, but it is within our IP address, we quarantine it. So those are the type of conditions it kind of looks at from a practical sense that I've seen before. But there are all different types of conditions that it can be used. So DLP, data loss prevention. This is pretty much when you want to prevent data, you want to prevent employees from accidentally leaking information, accidentally or intentionally leaking information, sensitive information for that matter. If you're working with legal, there's a lot of sensitive data, not only in legal, but with, accounting information or HIPAA information. So DLP is a system of security tools that is used to recognize and identify data that's critical to the organization and ensures that it is protected. So DLP can either be can monitor email. Two common uses of DLP: monitoring email through a mail gateway, or blocking and copying of files to USB flash drive, USB blocking. Most DLP systems use content inspection, defined as security analysis of transaction when it's approved context. So things to add to this. Additionally, we have CASB, Cloud Access Security Broker. Those are being used more and more these days to inspect not only emails that are going out and attachments that are going out, but also if you have different it integrates with different applications out there. So for example, it doesn't have to just be email. If you're using like Dropbox or Google Mail or your personal email, it integrates with all those different. A CASB solution integrates with all those different types of application and actually looks at that content to either block or trigger everyone or send notifications that data is being exfiltrated. Usually you want to leave it's hard sometimes you're going to be impeding business if you keep on blocking everything. So it's usually best to put it on just a monitor mode. And then if, unless, your business determines otherwise, it's all about the risk tolerance of your department and how much of an impediment do you really want to be to the business process. Other than that, also DLP, when it's you definitely want to categorize your data, and so or identify your data is probably most important, or the first thing you should do that involves with DLP. A lot of different software and your antivirus actually uses DLP. Or it's automatically baked into the system itself. So people can't transfer files to personal devices or not approved USB flash drives. So content inspection looks at not only the security level, but also who's requesting it, the data is where the data is stored, when it is requested, where it's going. And there's three types of DLP sensors: network sensors, storage sensors, and agent sensors. When a policy violation is detected by a DLP agent, it reports back to the DLP server, and it can either block the data, redirect it to an individual who can examine the request, quarantine the data until later, alert a supervisor of the request. Usually, it'll alert the user, usually through, practices, it'll alert the user. If we're talking about like USB stuff, it'll probably alert the user and request, the security team to allow it to go through. If it's email, usually we get alerts and then we do investigation if we allow it to go through, if it looks suspicious or not. Because sometimes it's hard to, sometimes your HR department needs to talk to, for example, in public, sometimes your HR department needs to talk to another HR department for if someone transferred, or you're talking to Cal HR. You're going to be sending back and forth sensitive information, and you can't just start blocking everything, or if your legal teams, are talking to different attorneys, you can't just block all sensitive data because that's legitimate. So you have to look at who's requesting it as well. So chapter summary: standard network security devices provide a degree of security. Switches, routers, load balancers, and proxies. Hardware devices specifically designed for security give higher protection level. Hardware-based firewall, web application firewall, VPNs are used for unsecured public network and encrypts your network traffic. A mail gateway monitors email. IDS is designed to detect attack as it occurs. A SIM aggregates all your logs together and used for incident response or troubleshooting. Methods for designing a secure network is to have DMZs and virtual LANs or VLANs. Network technologies to help secure a network is use a NAC. And that's about it.